So today we have an interesting geometrical problem. We take a square and draw its diagonal. Now we draw one more square such that one of its vertices lie on the diagonal and two of its vertices lie on the adjacent side of the previous square. Now if the length of this particular line segment has been taken as A and the length of this particular line segment has been taken as B, the question over here is to find the value of A upon B. So this is Anmol, and now let us see the solution. How can we solve this problem? Okay, now let us start with the solution. But before that, let me tell you a thing that I will be presenting two ways to solve this problem. The first method will be a trigonometrical approach and the second method would be a pure geometrical way. So let us start the solution with the first method. So as I told you, in the first method we are going to use the trigonometry, and trigonometry is all related to the side lengths and the angle. So first of all, let us mark the remaining side lengths in this diagram. So I will start the marking by taking the side length of the smaller square as a variable x and the side length of the bigger square as a variable y. Now I can see that the distance from here to here is also going to be equals to y. This much distance is already equals to a. Therefore, the remaining distance, that is from here to here, would have a value longer minus the shorter, that is y minus a. Now similarly, I can see that the distance from here to here is equals to y. This much distance is equals to b. Therefore, the remaining distance, that is from here to here, would have a value y minus b. Okay. Now as I told you, when we are using trigonometry, what we need is the side lengths and the angle. So the side lengths we have marked. Now let us mark the angles. So I can first of all say that all these four angles are going to be 90 degree because they are the corner of the bigger square. Similarly, these four angles are going to be 90 degree because they are the corner of the smaller square. Now I will simply take this particular angle over there as a variable theta. Now this is a straight line, this angle is theta, this angle is 90 degree. Therefore, this angle over there would have a value 90 minus theta. Okay, now let me ask you a question. Did we mark all the required angles in this diagram? So the answer is no. Recall that the position of the smaller square was defined by one of this particular fact that one of its vertices lie on the diagonal. This means diagonal is an important part of this question. Now we know this particular fact that because of the diagonal, the 90 degree in the square get equally bisected as 45 degree. So this was the angle that we have not yet marked. Okay. Now look carefully in this particular triangle. One of the angle is 90 minus theta, the other angle is 45. Therefore, by angle sum property, the value of the third angle would be equals to 45 plus theta. So here we have marked all the required angles also. So now let us proceed to the trigonometrical solution. So the first thing that I can see over here is that in this right angle triangle, we have the angle theta, we have the value for the base, that is b, we have the value for the height, that is y minus a, and the hypotenuse is ultimately the side of the smaller square, and that we have taken as a variable x. Okay, so in this right angle triangle, we can easily say that the value of cos of theta would be equals to b upon x. The value of sine of theta would be equals to y minus a upon x, and similarly the value of tangent of theta, that is tan theta, would be equals to y minus a divided by b. Okay, now I will take this particular triangle over there. So the triangle is quite messy, means it's small in the diagram, so I'll just redraw it outside the diagram. Okay, this angle is 45 degree, this angle over there is 90 minus theta, and this angle over here is 45 plus theta. Okay, now the value of this particular side we have got as y minus b, and the value of this particular side, that is the blue side, is ultimately the side length of the smaller square, hence it would have a value x. Now in this particular triangle, I will apply the sine rule. So as per the sine rule, sine of 45 degree upon its opposite side, that is x, this ratio would be equals to sine of 45 plus theta, the angle is over here, so this value divided by its opposite side, that is y minus b. Now this ratio would be equals to sine of 90 minus theta upon its opposite side, that is this one, and that is not a special, so we'll simply not take the ratio. Okay, we'll go ahead and compare these two ratios only. Now as I told you, we will be comparing these two ratios. So the first thing that I can do is I can open sine of 45 plus theta with the identity of sine of a plus b, that is sine of a plus b equals to sine of a multiplied with cos of b added with cos of a multiplied with sine of b. Now this is the identity, and in this identity if I simply replace a equals to 45 degree and b equals to theta, on the left hand side we will have sine of 45 plus theta, and this thing would be equals to sine 45 cos theta plus cos 45 sine theta. Now I know the value of sine 45 and cos 45, that is going to be 1 upon square root of 2. So I can simply take that common from both of this term, and what will be remaining inside is only sine theta plus cos theta. Okay, so the value of sine of 45 plus theta is this particular thing. So in that equation I'll go ahead and replace sine of 45 plus theta with this value. Okay, now let us rewrite this equation. So as we saw, the value of sine of 45 plus theta is going to be 1 upon square root of 2 multiplied with sine of theta plus cos of theta, and this thing is getting divided with y minus b. Now this thing is equals to sine of 45 upon x. The value of sine of 45 is 1 upon square root of 2 and x as it is. Now I can see that 1 upon square root of 2, 1 upon square root of 2 got factored out, and after the cross multiplication I can get y minus b equals to x times sine of theta plus cos of theta. Now recall that from the right angle triangle we have already got the value of cos of theta, sine of theta and tangent of theta. So the value of cos of theta and sine of theta from there I can replace in this equation. So the equation that I currently have is y minus b equals to x times, now instead of sine of theta we have its value, that is y minus a divided by x. This thing added with the value of cos of theta. Now the value of cos of theta from this right angle triangle is b upon x, so plus b upon x. Now we can see that the denominator of these two terms is equals to x, so we can simply take it common and it will cancel out with this one. Okay, so what we will finally get is y minus b equals to y minus a plus b. Now we can simply cancel out the y from both of this side, and after that if I will adjust the like terms I will get a equals to 2 times b. Now I can simply divide b on both of this side, so I will finally get the value of a upon b, and that would be equals to 2, and this is the answer that we were looking for. Okay, so here we have got the value of a upon b, and that is equals to 2, and we got this using trigonometric. That was basically our first method. Now let us see the second method, in which we are not going to use trigonometry, but instead of that we'll use pure geometry. I mean similarity, Pythagoras theorem and all that thing. Okay, so for that take the same diagram and just clear all the things that we used in the first one. Now I kept the markings for the side lengths as it is because they are required in the second method too. Now recall that this angle over there was 45 degree because of bisection of diagonal. Now what I will do is I will simply drop a perpendicular from this point to the top side of this square. Now look carefully, here we have formed a right angle triangle. One of its angle is 90 degree, the other angle is 45 degree. Therefore by angle sum property this angle is also going to have a value 45 degree. Now if the base two angles of a triangle are equal, the sides also become equal. Therefore this side and this side become equal, and let it be equals to a variable m. Now I can say that the complete distance from here to here is equals to y minus b. Sum of this distance we have taken as a variable m. So let us write down the remaining distance in terms of this variable. So distance from here to here is equals to m, and the distance from here to here was equals to y minus b. Therefore the remaining distance from here to here would be equals to y minus b minus m. Okay, now let us mark the angles. So this angle is 90 degree because it is the corner of the smaller square. This angle I will again take it as a variable theta. Now this angle is theta, this angle is 90 degree, this line is a straight line. Therefore the value of this particular angle over there would be equals to 90 minus theta. Now here we again have a right angle triangle. I am talking about this one. One of the angle is 90 degree, the other angle we have just got as 90 minus theta. Therefore by angle sum property this angle over here would have a value theta. Now what I can see over here is that this right angle triangle over here and this right angle triangle over there are similar to each other because all the three angles of these two triangles are equal. Now as these triangles are similar, we can take their sides as ratio. Now according to the correspondence, the ratio of the side would be like this way. M upon B equals to y minus b minus m upon y minus a equals to x upon x. Okay, now let us solve this equation. So the first thing that I can see over here is that the third ratio is x upon x, and that is ultimately going to be equals to 1. Okay, now as this thing is equals to this thing equals to this thing, I can say that m upon b is equals to 1 and y minus b minus m divided by y minus a is also equals to 1. Okay, now by solving this particular equation, I can get that m is equals to b. Okay, so here we have got the value of m, that is equals to b. So let us go ahead and put this value of m in this particular equation. So there is only one m present over there. So this equation will now turn out to be y minus b equals to y minus a. Now I can say that y and y got cancelled out. I will get negative 2 times b equals to negative a. The negative got cancelled out and I will simply divide b on both of this side. So finally I will get the value of a upon b, and that would be equals to 2. And this is the answer that we were looking for. So these were my ways to solve this particular problem. If you have any other method other than this, or else if you have any other question that you think I should try, you can do comment below, and if it's hard to comment, you can email me, or else you can send it to me on my Instagram. The link is in the description. And if you want to learn a cool geometrical theorem, you can click on the video that you can see on the screen. Okay, so if you enjoyed the solution of this particular problem, do like the video and share it with your friends. And if you want to see more geometrical problems coming in the future, make sure to subscribe to the channel.